Let's recap the concepts from matrices. So, a matrix is a rectangular arrangement of numbers in rows and columns. Um, so, for example, if you see here, I have written these numbers, let's say 2, -3, 5, 0, 1 by 2, and 100. So, I have written this in some rows and columns, and I have put a square bracket on both the sides. So, this represents a matrix. Now, like I said, that a matrix will have some rows and columns. We will have to write some numbers within those rows and columns and make sure that none of the spaces are empty. We need to have elements or numbers on all the spaces. Now, the next thing is about the order of a matrix. So, a matrix will have some rows and columns. If we count the number of rows and the number of columns of the matrix, we will be able to find, or we will be able to define, what's the order of the matrix. So, the first matrix here that we see here with these elements 2, -3, and 5, this is in the first row, and in the second row we have the elements 0, half, and 100. So, I can say that this matrix has two rows, but it also has 1, 2, and 3, column 1, column 2, and column 3. So, this matrix has two rows and three columns. So, I can say the order of this matrix is 2 by 3. 2 represents the number of rows and 3 represents the number of columns in this matrix. Similarly, the second matrix that you see, we have row 1, row 2, and row 3. So, we have 3 rows and we have 1 column and 2. So, total there are 2 columns. So, the second matrix has order 3 by 2, 3 rows and 2 columns. Then we will look at the different types of matrices. So, matrices can be classified into certain types depending on the number of elements that they have in the rows and columns, or the kind of elements that we have in the matrix. So, one arrangement is the rectangular matrix, where we will have the number of columns which is not equal to the number of rows. So, rectangular matrices are any matrix where the number of rows and columns will be unequal or different. For example, in the first matrix we have 2 rows and 3 columns. So, the number of rows and columns are different, and in the second example we have 3 rows and we have 2 columns. So, again it becomes a rectangular matrix. Now, suppose if I have only a single row, like I have written the elements 1, 2, and 3, it has a single row, but it has 1, 2, 3, 3 columns. So, any matrix having a single row will be known as a row matrix. So, a row matrix will have a single row and multiple columns. So, it is also a kind of a rectangular matrix. And if I have elements written only in a single column, for example, here I have these elements 1, 2, and 3 written in 3 different rows, but it falls under a single column. So, it will be known as a column matrix. So, a column matrix will have multiple rows but only a single column. So, it will also be considered as a type of a rectangular matrix. Now, in case we have the number of rows and the number of columns equal in a matrix, it will become a square matrix. For example, if I have a single element like this, it has 1 row and 1 column. So, I can say that it's a square matrix. And an element, if a matrix has only a single element, we can also say it's a singleton matrix. Alright. Now, suppose in this other example, I have 2 rows and 2 columns. So, it is also a square matrix, and I will say it's a square matrix of order 2 by 2, or if I just say it's a square matrix of order 2, it is understood it will have 2 rows and 2 columns. And in the other example, I have 3 rows and I have 3 columns. So, it's again a square matrix of order 3. Then suppose if in a square matrix, if I see that I have the elements in a special way, for example, if I look at this matrix over here, which has row elements 1, 0, and another the second row has elements 0 and 2, I can look at a diagonal arrangement of elements. For example, this this becomes my principal diagonal or leading diagonal in my square matrix. Uh, if you want to identify which elements fall under this principal diagonal, then you just need to ask yourself which is the element in the first row first column and second row second column, like that. So here these elements are 1 and 2, which are not 0, and all the other elements in the matrix are 0. So this is known as a diagonal matrix. Another example that you can see here is the 3 by 3 matrix, where the first row first column element, second row second column element, third row third column element, these three are the principal diagonal elements. These are not 0, but all the other elements are 0. So this is also a diagonal matrix, and this is of the order 3 by 3. So I will say that diagonal matrices are a type of square matrix where the principal diagonal elements will be non-zero and all the remaining elements will be 0. Now if I have a single matrix, like a matrix with a single element, only let's say 2, this 2 itself is a diagonal element. It's in the first row and first column, and there are no other elements anyway, so I can also consider this as a diagonal matrix. Now a diagonal matrix becomes another special type of matrix if in case the diagonal elements, the elements in the principal diagonal, are exactly equal to 1 and all the other elements are 0. So that I will call as a unit matrix or an identity matrix. So again, unit and identity matrices are diagonal matrices which are also in turn square matrices. So a square matrix can have order 1, order 2, order 3. So I have given 3 examples. So the identity matrix or the unit matrix of order 1 will have only a single element 1. If I am looking at order 2, then it will be 1 0 0 1 like this, and the principal diagonal elements are 1, the remaining elements are 0. And if I am looking at order 3, then my principal diagonal elements, these are all 1 and all the other elements are 0. Right. So then another type of matrix where all the elements are 0 is called a zero matrix or a null matrix. Now it can be either a square matrix, it can be a rectangular matrix, it can be column, it can be row matrix, anything as long as all the elements are 0, I will call it as a zero or null matrix. Now suppose if we have two matrices that are equal, the meaning is that both the matrices will have the exact same order and the corresponding elements will be exactly the same. So if I say that this matrix ABCD is equal to this matrix with these elements, then first thing is that these two matrices will have the same order, and in this case it does. Both of them have 2 rows and 2 columns, so the order is 2 by 2. And let's say the first row first column element should be the same. So I will say that in this situation A has to be equal to -1, then the first row second column element B has to be equal to 0. Moving on to the second row, so second row first column element C should be equal to 3, and then the second row second column element D should be equal to -5. Now suppose it is possible to add and subtract two matrices, but if we need to do that, we need to check whether the two matrices are of the same order. We can add or subtract matrices only if the two matrices have the same order. If we have matrices of different orders, we won't be able to add or subtract them. Okay, now suppose if we have matrices of the same order, then to get the result of addition or subtraction, we need to add or subtract the corresponding elements. So suppose here I have taken two matrices of the same order, which is square matrix of order 2, 2 rows and 2 columns. So if I need to do a subtraction, the first matrix minus the second matrix, let's say the first row and first column elements 5 and 4, we need to subtract. So we need to look at 5 minus 4, so we get 1. Then the first row second column we have 3 minus 6, so 3 minus 6 is -3. Then the second row first column, minus 1 minus of minus 3, we will get 2, and then the second row, second column, 0 minus 0 is 0. So this is how we add or subtract two matrices. Now we can do multiplication of matrices. One thing we can do is we can multiply a scalar with a matrix. Scalar in this context represents any real number. So we can multiply a number and a matrix. So the meaning is that we need to multiply all the elements of that matrix with the given number. For example, if I am multiplying this number minus 1 by 2 with this entire matrix, then each element I am supposed to multiply with minus 1 by 2, and then I will get the result. Now in case I wanted to multiply two matrices, then I need to look out for a couple of things. One is that this matrix multiplication of two matrices is possible only if the number of columns of the first matrix is equal to the number of rows in the second matrix, right? So this is the compatibility criteria for multiplication of two matrices. So a matrix A into B is only possible if the number of columns in the first matrix A is equal to the number of rows in the second matrix B. So for example, if the first matrix A had an order x by y, x number of rows and y number of columns, and the second matrix B has y number of rows and z number of columns. So first thing we notice that the number of columns in matrix A is equal to the number of rows in matrix B. So the multiplication is possible, and the resulting matrix will have an order equal to x by z. X represents the number of rows in the first matrix, and z represents the number of columns in the second matrix. So the resulting matrix will have the order x by z. Let's look at some example to understand it. Let's say I have these two matrices A and B. So matrix A has 2 rows and 2 columns, so its order is 2 by 2, and matrix B is a row matrix. It has only a single row and 2 columns, so its order is 1 by 2. Now A by B is not possible. The reason is, here the number of columns in matrix A, which is 2, is not the same as the number of rows in the second matrix, which is 1. So A by B is not possible, but if I look at B multiplied by A, then I have matrix B with the order 1 by 2 and matrix A is of order 2 by 2. Then the number of columns of B is the same as the number of rows of A. So B multiplied by A is possible, and the resulting matrix, let's call it matrix C, will have order same as 1 by 2. 1 is the number of rows in matrix B, and 2 is the number of columns in matrix A. So let's look at the multiplication B into A. So I will write the two matrices like this. Now I already know that the resulting matrix will have 1 row and 2 columns. So it will have a single row and 2 columns. So basically 2 elements. So suppose if I want to find what is the first row and first column, first row, first column element, then I take the first row of matrix B and the first column of matrix A, and I will multiply the corresponding elements. For example, the first element multiplied by this first element, 5 into 1, plus I will do 6 into 3, and the result is 23. So in the resulting matrix, the first row, first column element will be 23. Now the resulting matrix will also have another element, which is the first row, second column. So now I will look at the first row of my first matrix, and I will also look at the second column of my second matrix to get the first row, second column element of my resulting matrix. So I have 5 into 2 plus 6 into 4. So if I calculate, it will be 34. So this is how we multiply matrices. Now we can also find the square of a matrix. Suppose we have a matrix A and I want to find what is A square. So first thing is that for rectangular matrices, we cannot find the square. For example, if I had a rectangular matrix A with the order 2 by 3, then if I want to do A square, I have a 2 by 3 matrix and another 2 by 3 matrix. So then the number of columns in the first matrix and the number of rows in the second matrix are not the same. So we cannot take the square of a rectangular matrix, we can only do that for square matrices. Now let's say that A is a square matrix, and if I want to find what is A square matrix, we shouldn't simply square each element and then say that okay, if this is matrix A, this is matrix A square. That doesn't work all the time. For example, here suppose A is a square matrix of order 2 and I have elements 1, 0, minus 2 and 3. If in case by mistake I was doing A square like this, that okay, first element is 1, so 1 square is 1, second element 0, 0 square is 0, then the element minus 2 square will be 4, and then 3 square will be 9. So this is wrong. We will see that this is not true all the time. So to actually find what is A square, write the matrix A multiplied by A and then apply the procedure for multiplication of matrices. So if you do that, you will find the elements something like this. You will have 1, 0, minus 8 and 9. So you see that it's not the same. So you need to apply normal matrix multiplication to find the square of a matrix. And finally, if you compare the properties of multiplication of matrices and with the properties of multiplication of numbers, you will find that it's not exactly the same. For example, if I multiply 2 into 3, it is same as multiplying 3 into 2. But for matrices, multiplying matrix A with matrix B, it's not necessarily same as matrix B multiplied by matrix A. So in case of numbers, 2 into 3 being same as 3 into 2 is known as the commutative property. So it is not applicable for matrices. So if you look at your textbook, they have given some comparison between the properties of multiplication of matrices versus numbers. So it's not always going to be the same.